Assalamu alaikum dear students. On the behalf of KMES English Medium High School and Junior College, I, Mrs. Musliha Siddiqui, going to start the first chapter of physics for the students of the Standard 11th Science and IT. The first chapter of physics is units and measurements. First of all, let's see scope and excitement of physics and also why there is a need for measurements. Basically, there are two domains in the scope of physics, macroscopic and microscopic. The macroscopic includes phenomena at the laboratory, terrestrial, and astronomical scales. The microscopic domain includes atomic, molecular, and nuclear phenomena. The macroscopic phenomena deals mainly with the branch of classical mechanics, which includes subjects like mechanics, electrodynamics, optics, and thermodynamics. Mechanics based on Newton's laws of motion and gravitation is concerned with the motion of particles, rigid and deformable bodies, and general system of particles. The propulsion of a rocket by a jet of ejecting gases, propagation of water waves or sound waves in air, the equilibrium of a bent rod under a load, etc., are examples of mechanics. Electrodynamics deals with electric and magnetic phenomena associated with charged and magnetic bodies. Its basic laws are given by Coulomb's, Oersted, Ampere, and Faraday, and also encapsulated by Maxwell in the famous Maxwell's equation. The motion of current carrying conductor in a magnetic field, the working of an antenna, propagation of radio waves, etc., are examples of electrodynamics. The working of telescopes and microscopes and other optical instruments and phenomena involving light are examples of optics. Thermodynamics deals with examples like changes in internal energy, temperature, entropy, etc. The microscopic domain of physics deals with the constitution and structure of matter at the minute scales of atoms and nuclei and their interactions with electrons, photons, and other elementary particles. Classical physics is inadequate to handle this domain and quantum theory is currently accepted as the proper framework for explaining microscopic phenomena. When size of particle becomes very small, its physical properties may change. For example, gold is seen to have yellow color or golden color, but considering nano size, its color changes to pink. So, we can see that the scope of physics is truly vast. It covers a tremendous range of physical quantities like length, mass, time, energy, etc. At one end, it studies phenomenon at a very small scale of length, about 10 is to minus 14 meter or even less, involving electrons and protons, etc. While at the other end, it deals with astronomical phenomena at the scale of galaxies or even entire universe whose extent is of the order of 10 raised to 26 meter. The two length scales differ by a factor of the order of 10 raised to 40 or even more. The range of masses go from 10 raised to minus 30 kilogram, which is nothing but the mass of electron, to 10 is to 55 kilogram mass of known observable universe. Now let's see why there is a need for measurements. Experiments and measurements form the basis of physics. Hence, there is a definite need for measurements in physics. We can get the knowledge of the surroundings through sense of vision, hearing, touch, smell, etc. However, these quantities cannot be measured accurately by personal judgment. To measure and study phenomenon in physics, we have to perform experiments. Based on the observations of physical phenomena, we develop various laws and theories. Similarly, experimental verification of various theories needs measurements of physical quantities. Physics being a quantitative science, accurate measurements of physical quantities are needed at every stage. Many times. Now, next, let's see units for measurements. The very first question arises over here, that what is a physical quantity? So a physical quantity is a property of a material or a system that can be quantified by measurement, or we can say that a physical quantity is a quantity which can be measured there. And hence a physical quantity can be expressed as the combination of a numerical value and a unit there. Any physical quantity can be measured and expressed in terms of a number and unit. For example, if we say that the length of a rod is 5 meter, it means that its length is 5 times as large as a certain standard length called meter, which is the unit. Hence, for the measurement of a physical quantity, we need a certain reference standard. And a physical quantity possesses at least two characteristics in common, as we have discussed here in the example when the length of the rod we have considered as 5 meter. So over here, a physical quantity, we can say that it possesses at least two characteristics in common. One is numerical magnitude or a number, or other is the unit in which it is measured there. Like length is to be measured in meter, that's why here the measurement we have given as the length of rod is 5 meter there. And over there, the measurement of a physical quantity we are given over here, it needs a certain reference standard. So this reference standard which is used for measurement of a physical quantity is called a unit. Now, a good unit should have the following properties. As you can see over here, it should be easily available, first one. The next is it is invariable, that means not to be changed with space and time. That means as the place or space will be changes, time will be changes, the unit will not going to be changed there. Third property is it should be universally accepted, and the fourth one, it should be reproducible. As all over the world we are using a same standard reference, and because of this it is easily available, and hence we can reproduce it very easily. And also it is not going to be changed with space and time there, so we can say that it is invariable and it is universally accepted. So this is all about the units for measurements. As we had seen the basics of units and measurements, the scope of physics as well as need for the measurements, we have discussed units for measurements also. Let's see more about the chapter units and measurement. The next topic is system of units. As The units are classified into two groups: fundamental units and derived units. Fundamental units and derived units we will discuss in detail in the next topic. Here we should know that a set of fundamental and derived units is called system of units. In 1832, Gauss suggested to select any three physical quantities as fundamental quantities. Accordingly, many systems of units came into existence, and also we have come across various system of units, namely CGS system, MKS system, FPS system and SI system. The CGS system means centimeter gram second system. MKS system means meter kilogram second system. FPS system means foot pound second system. The CGS and MKS system were also known as metric system, while the FPS system was a British system used in Great Britain and some other English speaking nations. The use of the different system of units became very inconvenient for exchanging scientific information between different parts of the world. Hence, over here in Paris, a common system of units which is to be called as System International de Units, which is nothing but the SI units, was accepted. This international system of units called SI units, which consist of 7 fundamental units, 2 supplementary units and large number of derived units. The SI system has now replaced all other system of units and has greatly simplified exchange of scientific data between different parts of the world. Now let's discuss about fundamental quantities and units. The physical quantities which do not depend on any other physical quantities for their measurements are known as fundamental quantities. The 7 basic physical quantities are there, which is length, mass, time, temperature, electric current, luminous intensity and amount of substance, which are independent of any other quantities for their measurement, and hence these physical quantities are called as fundamental quantities. As we know that the measurement is to be given by means of a magnitude and a unit, so that for the measurement of these physical quantities which do not depend on any other physical quantities for their measurements, which is said to be a fundamental quantities, so the units of these fundamental quantities are called as fundamental units. The units which is to be used to measure fundamental quantities are called fundamental units there. Now let's have a table in which fundamental quantities are to be given with their SI units and symbol. Here you can see the fundamental quantities which is to be given: length, mass, time, temperature, electric current, luminous intensity and amount of substance. These are the 7 basic physical quantities whose measurement is independent. The physical quantities do not depend on any other physical quantities for their measurement. That's why it is said to be a fundamental quantity. The unit of the length is given as meter and symbolically it is to be denoted as m. As over here we have discussed that the SI system which is to be replaced all other system of units, that's why the units over here are to be given in SI system only. So these are the units which is to be given in SI system there. The next fundamental quantity is mass. and it is to be measured in kilogram, and the symbol of the mass we are using as kg. Then the third fundamental quantity is time, which is to be measured in second, denoted by S. Next fundamental quantity is temperature, which is to be measured in Kelvin, and the symbol of this SI unit is to be given as K. Then the fifth fundamental quantity is given as electric current, which is to be measured in ampere and denoted by A. Then the next fundamental quantity is luminous intensity, which is nothing but the intensity of light source that can be estimated by human eye. It is to be measured in candela and hence denoted by CD. And the last fundamental quantity is nothing but the amount of substance, which is to be measured in mole, and the symbol is to be given as MOL. So over here, these are the 7 basic physical quantities whose measurement is independent of any other physical quantities for their measurement, and hence these quantities are called as fundamental quantities. And the units of these fundamental quantities, which is to be given over here in SI units column, is said to be the fundamental units. Then let's see what is the derived quantities and units. So we come across a large number of the quantities besides these fundamental quantities. For example, is speed, momentum, resistance, conductivity, pressure, force, energy, etc., which depend on some or all the 7 fundamental quantities, and hence can be expressed in terms of these quantities only. These are called as derived quantities, and hence obviously their units, which can be expressed in terms of the fundamental units, are called as derived units. In simple way, we can say that the physical quantities other than fundamental quantities, which depend on one or more fundamental quantities for their measurements, are called as derived quantities, and unit of these derived quantities are known as derived units. For example, over here, as we know that the velocity is nothing but the displacement upon time, and hence the displacement is to be measured in meter, time is to be measured in second. So the unit of the velocity we are taking as meter per second. Okay, hence we can say that this displacement, which is nothing but the measurement of length, is nothing but a fundamental quantity. Time is also a fundamental quantity, and the velocity depends on the measurement of these two fundamental quantities, that is the length and time, and hence the ratio of displacement to the time is said to be a velocity. So this velocity is actually derived by using the two fundamental quantities, length and time. So this velocity is called as derived quantity, and the unit that we have obtained over here as meter per second. Meter is a fundamental unit, which is the unit of the fundamental quantity length. Second is the fundamental unit of the fundamental quantity time there. So this meter per second, which is the unit, depends on two fundamental units, and hence this is the unit of this derived quantity. That's why this meter per second is called as the derived unit there. So the physical quantities which depend on one or more fundamental quantities for the measurement is said to be a derived quantities, and the unit of that derived quantity is called as derived units. So here we have discussed about system of units with fundamental quantities and units, and also derived quantities and units. We will discuss it more and the chapter will be continue that we will see in the next lecture next time. Thank you.